Hey class, so it looks like school is going to be closed until May 1st for now. So I'm going to go ahead and record my lessons every week. And again, feel free to download it. And then if you need to pause it anytime while I'm going over the lessons or going over these problems, feel free to do so too. And if you want, it probably helps out if you have a piece of paper, pencil, and a calculator in front of you. Because while I'm going over these problems with you or the lesson, it's best if you practice while I'm going over these problems, okay? So for today, we're going to be learning about solution stoichiometry. Hooray! So I'm going to go over these two problems, and then that should be enough for you to understand for this week's lesson, okay? So here's the first problem. How many grams of zinc chloride should be produced if you react 125 mils of a 0.100 molar HCl solution to excess zinc? Okay, so since it is a stoichiometry problem, which you know you really enjoy doing, make sure you have a equation in front of you to work with. Okay, so here's the equation given. Solid zinc is reacting with hydrochloric acid, which is HCl, and it produces zinc 2 chloride and of course hydrogen gas. Okay, so first things first, you got to make sure the equation is balanced. So I'm going to go ahead and balance this. This should be 1. Zinc should be 1. There should be 2 hydrochloric acid or HCl. Go. 1 zinc chloride, and of course 1 hydrogen gas. Okay, cool. All right, so where do we start with first? Looks like you have a 0.100 molar HCl. Okay, so remember from last week, 0.100 molar means you have for every one, write this down. So it's saying for every 1 liter of hydrochloric acid, you have 0.100 molar of HCl. So what I'm going to do first is I'm going to take my volume. I'm going to convert that to liters first. And of course, how do you do that? It's just divided by 1,000. So which means it's going to give you 0.125 liters of hydrochloric acid. Okay, so what am I supposed to do with the volume and the concentration? So I'm going to multiply those two together. So take my volume, and of course, if you're to multiply it to your concentration, you're going to get the number of moles for hydrochloric acid. So here we go. I'm going to do 0.100 moles on top and 1 liter at the bottom of HCl. There we go. Okay, so notice when you take your volume and you multiply it to your concentration, you're going to get the number of moles for HCl. Okay, so remember, the question is asking you to find the grams of zinc chloride. So right now I have moles of hydrochloric acid. So the next step I want to do is use the mole ratio to go from moles of HCl to moles of zinc chloride. Okay, so I'm going to set this up. Moles of HCl at the bottom and moles of zinc chloride at the top. Let me just move this over. Zinc chloride at the top. Okay, so the next thing, look at your balance equation. What's the mole ratio for every 1 mole of zinc chloride? You have 2 moles of hydrochloric acid. Okay, cancel for the moles of hydrochloric acid. Okay, are we done? Not quite. Now we have moles of zinc chloride. And of course, the next step, what you want to do is you want to go from moles of zinc chloride and convert it to grams of zinc 2 chloride. So how do we do that? You got to use the molar mass of zinc chloride to determine that. Okay, so I'm going to go ahead and move it over here. Times. Okay, so you're gonna figure out the molar mass for zinc 2 chloride by using your periodic table, but I'm going to make it easier for you. It should be 136.31 grams for every 1 mole of zinc chloride. There we go. Moles cancels out. And then you have grams at the top. And then, of course, that is it. Very last thing you want to do is you want to calculate this. So with a calculator, again, you're going to take 0.125 times 0.100. Okay, divided by 2. And of course, the very last step is multiply it to 136.31. Okay, so if you're going to get this on your calculator, you're going to get 0.8519375. Okay, remember, since these are measured numbers, you have to account for significant figures. Okay, so 125 is 3 sig figs. That's a measured number. The 0.100 molar, that's 3 sig figs, also a measured number. Since we're multiplying, you need 3 sig figs at the end. So I'm going to keep the 80, the 851 is the cutoff point. So that 9 is greater than 5, so you're going to round it. So it should be 0.852 grams of zinc chloride being produced at the end. I'm going to box my answer. There we go. So let's come back to the question again. So it says how many grams of zinc chloride should be produced if you react 125 mils of a 0.100 molar of hydrochloric acid solution to excess zinc. So at the answer at the end, this is how many grams of zinc chloride being produced, the 0.852 grams. Okay, why don't we look at just one more problem, just so you can get used to understanding how to deal with these stoichiometry problems when you have concentration for molarity. Okay, so the last one. Here we go. Calculate the volume in liters of hydrochloric acid, which is HCl, if there are a 1.50 molar hydrochloric acid solution and a 28.4 grams of sodium carbonate. Okay, so here we go. At the bottom, here's my balance equation. You have HCl plus Na2CO3 yields NaCl plus water plus carbon dioxide. Okay, so same thing. You got to make sure you balance the equation. So there should be 2 hydrochloric acid, 1 sodium carbonate, 2 sodium chloride, and of course 1 water and 1 carbon dioxide. Okay, so what's given? You're given the concentration of HCl. Here we go. You're given the mass of sodium carbonate. Notice that's the reactants for both of them, okay? And of course, you need to find the volume of HCl. So where do I start with first? First, I'm going to use my mass right here, the mass of sodium carbonate. And what I want to do is I want to convert it to moles first, okay? So I'm going to show my work. I'm going to start with 28.4 grams of sodium carbonate. Okay, same thing. How do you convert it to moles? Go ahead and use the molar mass. So this time you're going to divide by the molar mass of sodium carbonate. Okay, so again, use the periodic table, add up the individual molar mass, and it should be 106.01 grams. Top should be 1 mole of sodium carbonate. Okay, so cancel. This should be sodium carbonate. Okay, times. All right. Next. What's next? Okay. Notice the problem is asking you to find the volume of HCl. So which means we're going to have moles of sodium carbonate. So it's kind of the same as before. You got to go from moles of sodium carbonate to moles of HCl. So you got to use the mole ratio. So moles of HCl at the top. Of course, moles of sodium carbonate at the bottom. Okay, I'm going to check my balance equation. So it looks like we have how many moles of HCl? 2. And how many moles of sodium carbonate? It's going to be 1. So it's 2 on top, 1 at the bottom. Moles cancels out for sodium carbonate. Now we have moles of HCl. Almost done. Okay, how do you figure out the volume if I'm at this point I have the moles of HCl? So this is where I'm going to use the concentration for HCl. Notice the concentration given is 1.50 molar. Okay, so I'm going to set this up. Instead of multiplying to the concentration, I'm going to divide it by the concentration this time. Okay, so which means 1.5 moles of HCl. Okay, on top it's going to be 1 liter, right? Because by definition, 1.50 molar, same thing as for every 1 liter of the solution, you have 1.50 mole. So cancel. There we go. So looks like I have liters, and now the very last thing I want to do is I want to calculate this by using my calculator. Oops. Okay, so just take 28.4 divided by 106.01 times 2 divided by 1.50. Okay, so it should say this on your calculator, 0.357199. I'll stop right there. Okay, so how many sig figs should you have for your answer? So let's check. 3 for the 1.50 molar. And of course, you have 3 sig figs for the number of grams of sodium carbonate. So same thing, you need 3 sig figs for your final answer. Okay, so I'm going to keep the 0, the 3, the 5, the 7. So here's my cutoff point. So notice the 1 is less than 5. So your answer at the end should be 0.357 grams. Excuse me, not grams. Oops. Should be liters of HCl at the end. There we go. So let's look at the question again. It says calculate the volume. So how many liters of HCl if you mix or react 1.50 molar of hydrochloric acid with the 28.4 grams of sodium carbonate. So it looks like the volume should be 0.357 liters of HCl.